Now let's look at voltage sources in a series circuit. So voltage sources can be connected in series to increase or decrease the total voltage applied to a system. The net voltage is determined by summing the sources or adding them together with the same polarity or direction and subtracting this total of sources with the opposite polarity or put in the opposite direction. Okay, so the net polarity is the polarity of the larger sum, meaning the direction of the net voltage is the direction of the larger sum, either summing the sources in one direction or the other, depending on what you have. So in this case, we have a 2-volt source, so starting at ground, that goes from negative to positive, so that's a voltage rise of 2 volts, and then we have another rise of 6 volts, and another rise of 10 volts. So these are all in the same direction. So we would add those together, 2 plus 6 plus 10, or 18. So the net voltage we're supplying to our circuit is 18 volts. In a typical circuit where you might put 4 double A's in the circuit, they would be lined up just like this, all in the same direction. So when you have 4 double A's and each of those are 1.5 volts, you would be applying 6 volts to your calculator circuit. So let's look here. Here we've got a 4-volt source in the upward direction. We have a 3-volt source in the opposite direction and a 9-volt source in the opposite direction. So we would add all of the sources in this direction, which is just the one source, which is 4 volts. And then we would add these together in the opposite direction. 9 and 3 is 12 volts, so in the opposite direction. So the difference would be 12 minus 4, or 8. And since we had more voltage in that downward direction, that is the direction of our 8-volt source. Okay. In this case, let's work a couple problems and see how this works. So let's look at our voltage sources in series here and see if we can calculate our current after we combine our voltage sources and resistors in each of these circuits. Okay, so in the first circuit, we have the 8-volt source here, the 16-volt source here, and the 4-volt source here. So the first thing we want to do is kind of establish the direction of each of these. So our 8-volt source goes from minus to plus, and we're continuing in the same direction, so minus to plus. The 16-volt source is plus to minus, and the 4-volt source is minus to plus. So that means we've got in this direction, we've got 8 plus 4, or 12. And in the opposite direction, we've got 16. So that means that our net voltage source would be 16 minus 12, or 4 volts, and it's going to be in the direction of the larger one, so it's going to be in that direction. So if I were to redraw this circuit, I would draw it with a source that looks like the 16-volt source with the positive side over here and the negative over here. And that would be 4 volts. And then my resistors I'm going to combine. I've got 2 resistors here. So RT would be 4.7 plus 5.6, or 10.3. Okay, so I sub S would be 4 volts divided by 10.3. Again, that's just Ohm's law. So if you're still unsure of that, please review Ohm's law. And that would be about 388 milliamperes. And the direction would be from the positive terminal back to the negative right here. So in that counterclockwise direction for that circuit. Let's look at the second circuit here. We've got our 4-volt source here, 18-volt source here, and a 12 over here. Now it's okay that they're separated by some resistors. We can slide those around and rearrange and still not change the current that we're supplying to the circuit. So that's just fine. So what we want to do is figure out the direction. So my 4-volt source is plus to minus. So I'm going to start with that. Okay, so we have a 4 volt in that direction. The 18 volt source is in the opposite direction, so I'm going to draw that over here. And the 12 volt is actually in the same direction as the 18. As the 4, because it's also in this clockwise direction. It's going from plus to minus this way. Okay, so we have 16 volts in this direction, 18 volts in the opposite direction. So that net is going to be 18 minus 16, which is 2. And it's going to be in the direction of the larger of the two, which is the 18. So when I draw this in my circuit, it's going to look just like this. And then the total resistance, and that's 2 volts. And the total resistance is going to be the 4.7 plus 1.2 plus 5.6, which is 11.5 ohms. When I plug that into Ohm's law, I sub S is going to be 2 volts divided by 11.5, which is 174 milliamperes. So as long as we're paying attention to the direction of our voltage sources in series, we can combine them, and we should when we're trying to find our total current for our circuit.